So let's wrap up what we learned today. We spent a lot of time talking about circuits. Um, you know that V equals IR. This is Ohm's law. The voltage is equal to the current times the resistance. And that is true for every part of a circuit. It's true for the whole circuit, and it's also true for each resistor. You also know the power is equal to the current times the voltage. You use that quite a few times to find the power, right? So our circuit model looks like this. You can think of the battery or your wall outlet or whatever you're using as a source of energy. You can think of it as an escalator on a marble run. It adds energy to the charges. The charges then flow around the circuit through the wires, and then they go downhill. They lose their energy, and something gets that energy. We call that a resistor or a load. So the battery might be the battery in your phone, and the load might be the screen, which lights up to show you your pretty pictures on Instagram. Or maybe it's the radio, which sends your text messages to your mom. But it's a load, it uses the energy. So that was our model, okay? We're going to draw that schematically like this. This is the source of energy. That's like the battery, the escalator. The charges flow around the circuit, and this squiggly line is the load. It's where the energy is going. Okay? The charges lose their energy, and then they roll back to the battery where they get more energy. Okay? So, in the lab today, we talked about series resistors. So here's the important thing. When resistors are in series, the current has to go through one and then the next. So any charges which go through one then have to go through the other before they can get back to the battery. That's a series circuit. Here's a model of what a series circuit looks like. The battery is still adding energy to the charges. They roll along the marble run until they do some work. They give up their energy to something. So here's a load, a resistor. But they can't give up all their energy because they still have to go through the other one. So how much energy they give up some of their energy here, and they give up the rest of their energy here as they do work, as they make something happen. So we have two resistors in series. Note that any charge which goes through the first one must go through the second one. And also note that the flow through the first one is the same as the flow through the second one. Okay? So when we have series resistors, the same current flows through both resistors. It goes through one and then the other. The sum of the energies that are lost. So if you measure how much it drops here, the energy drop, and you measure the energy drop here, that's got to add up to whatever the battery gave them in the first place. Okay? So when we talk about energy drops, that's really voltage. So the voltage of the battery must equal however much voltage is lost here plus whatever voltage is lost in the other one. So for series circuits, the currents are all the same. Whatever flows out of the battery is the same as what goes through resistor 1, and it's the same as what goes through resistor 2. The voltages add up, and the resistances add up. You figure that out from the lab. The total resistance is the resistance of one plus the resistance of the other. All right? So that's what happens for series circuits. Now, we're kind of hustling through this class at double speed because we're on the quarter system, so I'm not going to worry about solving problems. Just a quick note, though, that if you have a series circuit and one bulb goes out, the current can no longer flow. That stops the current, and all the bulbs go out. Maybe you notice that in your Christmas lights. Sometimes when one bulb goes out, a whole section of the string goes out. That's because that section is in series. So we're going to skip the problem solving here. I'll just hustle through this. We're not going to do that. The other kind of circuit that we have sometimes is a parallel circuit. When resistors are in parallel, the current splits up. So here's our model of a parallel circuit. The battery adds energy to the marble run, and then some of the marbles can go this way, and others go this way. This path here has less resistance, and so more of the marbles go this way. You'll notice that the flow through both of them is not the same. So the current in this resistor is not the same as the current in that resistor, but what is the same is the drop, okay? So the energy that's lost here and the energy that's lost there are the same because they both have to get back to the ground to go back to the battery, the escalator, okay? So whatever current goes this way through the 30 ohm resistor and whatever goes this way, the sum of those two has got to equal what's going through the battery. We draw it like this. And when we have parallel resistors, the voltages are all the same. The currents add up, so whatever goes through I1 plus whatever goes through I2 is the total. And then this was the goofy one that was maybe surprising to you. The resistances, to find the total resistance, you got to use reciprocals. So 1 over the total resistance is 1 over R1 plus 1 over R2. Okay? We are not going to solve a problem for this. We're just going to hustle through. Here is the summary. So what I want you to know, and what I might ask you about on the test, is can you find the total resistance if you have two resistors and you know they're in series or you know they're in parallel? Can you find the total resistance? And do you know that when they're in series, the currents are all the same for series, and in parallel they add up? And the voltages add up in series, and the voltages are all the same in parallel. Okay, so this here is a summary. That'd be a good thing to pause the video and put that chart in your toolbox as the last thing. Other than asking conceptual questions and maybe asking you to calculate the total resistance, I'm not going to ask you to solve problems involving complex circuits like this, okay? But we just kind of wanted to get a quick overview of what happens and how it all works. When you take college again and take physics again in college, you'll dive into this much more deeply. All right, so pause and get that in your toolbox, and then you are done for the day.